All right, guys, so this is the second video for section 7.2, and you should have already done like all the parallelogram properties, the definition, and all the theorems that come with it. And this is a follow-up to that video. So if you haven't watched that video first, please go back and watch that video first. Otherwise, this won't make any sense. All right, so let's look at example 1. Now, example 1 wants to find the values of x, y, and angle k. Okay, well, x is here. Let's find x first. So to find the measure of angle x. All right, so to find the measure of angle x, we know that this here is 2x and this is 50. And we know that the parallelogram opposite angles theorem tells us that opposite angles are what? Okay, the parallelogram opposite angles theorem tells opposite angles are congruent. So if these two are congruent, that means they're the same measure. So I can simply set up 2x equals 50 divided by 2, x is 25. Easy peasy. All right, so now let's look at y. Okay, so y is over here, y plus 3. And y plus 3 is talking about this side here. Okay, so we know this side is y plus 3, and we're given that this side is 18. So we have a theorem that tells us something about opposite sides of a parallelogram. So the parallelogram opposite sides theorem tells us what? Okay, parallelogram opposite sides theorem tells us that opposite sides are congruent. Okay, so if they're congruent, if this is 18, that means this has to be 18 as well. So I can say y plus 3 equals 18. And then y equals 15. Okay, so last but not least, let's find the measure of k. Well, we know this is 50. We know x is 25, so if we plug it in, we know this is 50. Okay, we have one more theorem. Okay, and that theorem is the parallelogram consecutive angles theorem, and it tells us that consecutive angles, which are side by side, tells us that consecutive angles have what relationship? Consecutive angles are supplementary, okay, meaning that they add to 180. Okay, so I can say that 50, or even these two add to 180, it doesn't matter. So I can say 50 plus angle k equals 180. Subtract 50 from both sides, I get angle k equals 130 degrees. All right, let's look at example 2. Okay, now example 2 has to deal with the diagonals. Okay, so I want you to look real quick at the parallelogram properties you just did and read the parallelogram diagonals theorem. Okay, that theorem tells us that the parallelogram, the diagonals bisect each other. So if they bisect each other, then this has to be the endpoint, which means that, let me get my highlighter here, which means that this length is the same as this length, and it also means that this length is the same as this length. Okay, so if we write that out in math terms, that means 5y minus 16 is going to equal 3y, and it also means 2x plus 10 is going to equal 4x minus 2. Okay, so just go ahead and do this one first. Minus 2x on both sides. I get 10 equals 2x minus 2. Let's add that 2. 12 equals 2x. Divide both sides by 2. I get x equals 6. And then if I go back to my y equation, I'm going to subtract 5y. So I get negative 16 equals negative 2y. Divide both sides by negative 2. That goes away. Negative divided by negative is a positive, so I get 8 equals y. All right, let's look at example 3. Now, I have my 3 coordinates plotted, so I'm going to pause this, and I want you to plot the coordinates that are given to you. All right, after you plot the coordinates that are given to you, you're going to see this kind of like awkward looking capital letter L, okay? And it wants you to figure out where is the 4th coordinate, or where's the 4th point, the vertex, which is going to be y, that would make this a parallelogram. Okay, so most of you can look at this and say, oh yeah, well that means it's going to be somewhere in this vicinity. Probably not that high up, but somewhere in the first quadrant. Okay, so what we're going to do here, guys, is we're just going to count. Okay, so we're going to say from W to X. Okay, so we're going from point W to point X. We're going to go left 1, 2. We're going to go left 2 and up 1, 2, 3, 4, 5. Left 2, up 5. Okay, so from Z to Y, we're going to do the same thing. We're going to go left 2 and up 5. So we're going to go left 1, 2, up 1, 2, 3, 4, 5, right here. This is going to be my Y. And of course, I want to connect it. And then I want to just double check to make sure it looks like a parallelogram, and it does. Okay. Now, if you didn't want to go from W to X, you could have also gone from W to Z. This is just another way, guys, which would have been down 1. So down 1 over 1, 2, 3, 4, 5, down 1, right 5. And therefore, from X to Y, you also would have went down 1, right 5. So down 1, right 1, 2, 3, 4, 5 would have been right there. So Y is at, what is that, 2, 1? And that would be it.